My name is Ottoson, and I'm the Managing Director for Radar Bolaget. And I'm going to talk about radio and radar measurement in harsh industry. The first block will be about, very shortly, about radio and radar technology that we are using. The second block will be some industrial implementation broadly, and then I will focus on the forest area, especially in moisture content and wood chips. Our radar system is a broadband, ultra-wideband system. Normally, a radar system is a narrowband system. And the good things with the ultra-wideband system is that you can do distance measurement directly with the signal. And it's very robust, and it also have a high accuracy. So this is a steel plate. This is just an animation. And the radar is not as laser. It's like throwing a ball on something, but it bounces back. But it have about the same accuracy. This is a steel plate that we are moving towards the radar sensor. And this is how the original radar signal look like. But if you process it, it looks like that, and that signal has very high accuracy. For example, in this case, when we are measuring a steel strip with a width of 1 millimeter, we can achieve an accuracy below 0.1 millimeter. We ourselves, we are developing the radar board on a radio board. And radar is when a radio signal is reflecting. And when I say talking about radio transmission, we are sending from a transmitter to a receiver, and we use that for material investigation, as I will show. Early, we started to work together with a German company that made this centering measurement. They used inductive sensor, which they placed inside the furnace. So this is a very hot furnace, about 900 degrees, and you can imagine that it's a quite fast degradation of these sensors. So they wanted to exchange this sensor with a radar sensor. So now they're using our radar, and they build a full product, and they use this centering functionality to control the centering of the steel strip with rollers. So it's a closed loop, you can say. And of course, when you're having the sensor outside the furnace and measuring through the insulation, it's easier to maintain. They will not be degraded so fastly either. And the biggest thing is that you don't have to shut down the factory just replacing the sensors. We are also working ourselves in this field. This is an image from SSAB, the Swedish steel company. We are working with a project where we're actually measuring expansion of steel slabs. A furnace owner, they estimate the temperature of each slab in the furnace to optimize this heating process. But what we are actually doing is that we see each slab as a big thermometer that's expanding. And if you know how they expand in different kind of temperature, you can actually measure the temperature, and they are estimating, and then we're trying to take away this deviation, so they control the furnace control system more efficiently. And that, of course, saves a lot of money, increase productivity, and the most important thing is that it increased the quality of the steel slabs. Sorry, that was, I was too. We also work, perhaps I should, I was too quick here. We also work, we have a Finnish connection. We work together with Nordkalk, the limestone lime manufacturer. What we are doing together with them, we developed this test furnace where we placed one receiver and one transmitter on each side of the furnace. We use these containers where we fill the containers with limestone or, in that case, cement. And then we put the container inside the furnace, and we start heating up to about 1300 degrees sometimes, and 900 for limestones. And what is happening is that the microwaves are sensitive to temperature and density. And during the process of burning limestone to lime, which says that it goes from calcium carbonate to calcium oxide, then the density will be lower. So you can actually measure the calcination level. And this is something Nordkalk want to implement in this shaft furnace. This is a bit 20-25 meters high. And they wanted to implement this in the burning zone, which is right here. So we have carried out successful tests in this burning zone, and they want to control the furnace control system in this case also. So in this case, they go from 16 hours of delayed testing of calcination level in the outcome of lime, and they do it every second or fourth hour. With our system, they can do it automatically, directly in the burning zone, and control the system directly. So, and this is a 5-meter width of this shaft, and we're measuring by transmission through from one side to the other one. And we just now, right these days, we are going to implement the shaft installation for them. This is more connected to the forest industry. We have been working together with the forest company Billerud-Korsnäs and Gävle Energy, which is a district heating company in my hometown. And what we did here is actually measuring the wood chips, the moisture content of wood chips directly in the trucks. We found out that, or I found out that the trucks has glass fiber walls, and every one is 2.6 meters. So for me, it was test boxes moving in front of my sensors. So we placed this sensor in front of the weight, and by moving the trucks, we can measure it, the whole truck, in 10 seconds. Instead, today they have to take out 6 liters or 100,000 liters as samples. They put it in a bucket, move it around, and then they take out 1 liter of them, and they put it in a heating cabinet for drying. And that takes about 24 hours. And they make it for correct payment. Correct payment, it's hardly because the sampling process is very hard. Everyone understands that statistics, 6 liters of 100,000 liters is not always representative. But the hardest thing is actually they cannot use this information to make some logistics on the fuel plant. For example, organizing the piles in wet piles and dry piles. So what we're offering is a very fast but also more accurate way of measurement, so we can open up for more logistics and improve the process on the fuel plant. I'll come back to that later, but since I saw so many drones yesterday, I wanted to show how we implemented the radar system on a drone. We made this on what I call Creative Monday. My technician put a battery on this radar system. You see it's not very big. And we placed antenna looking down. And the good thing with the radar system, it can look beneath the Earth's surface, and it can also penetrate, for example, trees. So it can, the military use it to find shelters and so on beneath the surface. It's more a matter of frequencies, how far down you can see actually. You can even see mines if you want to do that. We work normally in the 2 gigahertz area or 3 gigahertz area. But we use the same radar system. The only difference is how you speed up the system and the choice of how big the antenna shall be. Back to moisture content and the forest industry. This idea came up 5 years ago. They was talking about they had problem with the moisture content of wood chips in piles at Billerud-Korsnäs, and they asked me to measure it, and this ended up with this truck measurement instead. But the reason why it works is because in the same way as microwave ovens works, water molecules have 2 hydrogen atoms and 1 oxygen atoms, and when they are under influence of a microwave, they start shaking like that. and it's a lot of energy it takes up, and it interferes with the microwaves. So what actually is happening, it slows down the microwave. So it's a delay of the system, and this delay is directly correlated with the moisture content. But there are a big difference between liquid and ice, because ice is not sensitive in the gigahertz area, it's more sensitive in the kilohertz area. So you have to handle it differently. We found out that the accuracy can be about 1 to 2%. When we made some reference measurement, it's the black dots here, it was actually so good with our model, so it's down to 0.3 percentage points. If anyone is interested, we have published it in the IEEE paper journal. What we are looking forward to do is involving moisture content measurement in the whole process, from transportation to the local process. So that means that you can involve other parameters like dewatering, controlling the transport to go to that plant or that plant. But at the fuel plant, you can make a sorting, you make the correct payment, but you also can make the right recipe for combustion, because the combustion is sensitive to have all the same moisture content all the time. So we're actually planning to have, we have made some, which I will end up with, some measurement in a tractor bucket, and that can be used before transportation. So we actually know which kind of moisture content is inside the truck by knowing it from the tractor bucket. We can use it from deforestation areas, measurement directly in the truck. But we will also have this kind of scanner. We will modify it because we want the sensor to be closer to the truck. And then we'll check it before it's feeding up in the furnace. So this is how it looks like. This is the tractor bucket here. I will show that in the end also. Everyone is quite straightforward. The only one that is not straightforward, but because it has not the fixed distance, is on the conveyor. So there we need an extra sensor as well. What are the technical challenges? First of all, when you're talking about radio, I've heard about dangerous laser class 1 and class 2. We have some regulation also, and that is by influencing with radio, mobile telephones, and so on. It's not dangerous at all, but we have to follow CE markings and so on. And I said we have to differ between frozen and tempered wood chips. That's important. And accuracy, we have proven that it has high accuracy, but to increase the accuracy, we have to consider different kind of wood chips. We work with bark, recycled tree, and so on. But it is always the reference measurement that is the most complicated, just taking out the correct samples from one truck. So in the future, the low-hanging fruit, someone asked about that yesterday. As we see it, the low-hanging fruit for us is, I think it's a tractor bucket, because you can find it all over in the process. When you're loading, you are deloading, you are making sorting, you can find it on small fuel plants and big fuel plants. And we tested that together with an entrepreneur, and we had real good results. We should move the sensor a bit lower, and in the real case, the tractor bucket is much bigger, 15 cubic meters or something like that. And that will be tested in the next project. And this is an example of the next generation of truck scanner. In this case, we are still moving the truck, but we have also looked into a solution where we can actually scan a fixed truck also, like a big car washing machine. So, yeah, that's all, folks.
Thank you. This is also the topic what is discussing many years about the moisture in the forest chips and so on. So do you have already some connections or some partners in Finland?
I spoke to a Finnish company last week, Vapo. They're working with peat, so they are very interesting and in finding out the moisture content in peat. And they also have a lot of Swedish factories, so we are probably will carry out some tests with peat. So it doesn't matter if it's peat or wood chips. It have a probably different model, but it's just a matter of calibration, as I see it.
So when this is so ready that you can buy it in from the market?
It's not so ready. First we thought it was very easy that you can, but then first we got the problem with the sampling process and the reference measurement, because we thought that we had, before this year, we had 6,000 trucks running and we measured every one. And then we thought that we should correlate our measurement with the reference measurement, but it was like, the reference measurement was like a shotgun. It was dots all over the place because the sampling process is too bad. So we had to make it very carefully if we were going to compare it with our. We thought it was our technology that had inaccuracies, but actually it was the reference measurement that had inaccuracy. And then it occurs with this one, with the frozen one. So, and that had to be considered as well.
So you already pointing out some technology challenges.
Yeah.
But what is the main challenge? So what is the most difficult part to using this in the real applications?
You have to be along with approval for FCC for radio transmission. That's one challenge, because you can always turn up the power, whatever. But of course it's not dangerous, but you cannot have radio sources sending out, and then you cannot use other radio equipment. That is one big challenge, that you have to adapt to a standard. But perhaps you can get away with it and be approved to use it within this industrial area. So that's also a solution. But the biggest thing is that to find the right frequencies, because you want the water to be influenced, but you don't want it to stop the radio signal also. So you have to fine-tune the radio frequency and have the right calibration of your system. That's the big thing. And for that you need this ultra-wideband, because a narrow-band system doesn't work at all. So.
Thank you, Patrick, for coming and for that nice presentation. So in the first generation of your device, so does the scanner was moving for 10 seconds along the track, or the track was going so fast that?
No, it was the track that was moving in front of the sensors. So we thought it was a good idea using that moving vehicle in front of that. One problem with that one was that some drivers, they run very fast and someone was driving very slow, and they didn't crash into because it's a weight, so they had to place it on the weight, so it didn't crash into the sensors. So, but as you see here, one big obstacle was that the mirrors was in the same height as a sensor, and we had to place it in this height, because otherwise we measured on top of the wood chips. And then we also find out a big challenge is actually when it comes really wet wood chips. Then they pile it in, as I say, a camel and a dromedar. So it's like pies is not filled up. So that's a challenge, because then we measured above the wood chips. So that was also a challenge. So it was very good, and it worked when we put it on the right height and when it was filled up in the container. So that's something that has to be considered.
In the second generation of your device, you use the same approach. So the car was moving along the radar, like as you said, in a car washing system.
Yeah, we have considered both. We haven't decided yet. The problem with this truck washing machine is that, of course, it's quite expensive. It doesn't cost extremely much, but it costs about 80,000 euro. I asked manufacturer of this one if it's possible to take away the brushes and place, and they said, well, of course we can do it. So we are not sure at the moment.